Beverages marketed as zero sugar or sugar-free have become a staple in modern diets, especially among individuals attempting to reduce caloric intake or manage blood sugar levels. At first glance, these drinks appear to offer a convenient, guilt-free alternative to sugary sodas, juices, or energy drinks. However, the zero sugar label can be highly misleading, masking a host of metabolic and liver-related risks that undermine their intended health benefits. While these beverages eliminate calories from sugar, they almost always contain artificial sweeteners such as aspartame, sucralose, acesulfame K, or saccharin, along with flavor enhancers and acidic additives, all of which interact with the body in ways that can paradoxically increase appetite, cravings, and liver stress. One of the primary concerns is the effect of artificial sweeteners on gut-brain signaling. Sweet taste normally informs the brain of energy intake, triggering satiety pathways that regulate appetite and caloric consumption. Artificial sweeteners, however, provide sweetness without actual energy, creating a disconnect between sensory perception and metabolic reality. Over time, this mismatch can blunt satiety signaling, tricking the brain into expecting calories that never arrive. As a result, individuals may unconsciously compensate by consuming larger portions of food or seeking high-calorie snacks later in the day, effectively negating the supposed benefit of avoiding sugar. This cycle of altered appetite regulation promotes a hidden, cumulative caloric surplus that directly contributes to fat deposition, including in the liver. Artificial sweeteners also influence hormonal regulators of hunger and satiety. Compounds such as aspartame and acesulfame K have been shown to modulate ghrelin and leptin levels, increasing hunger signals while decreasing the brain's sensitivity to fullness. Over time, this hormonal disruption encourages overeating and snacking behavior, increasing the risk of non-alcoholic fatty liver disease, NEFLD, and insulin resistance. The metabolic burden of repeated overeating compounds liver fat accumulation, oxidative stress, and inflammation, illustrating that zero-calorie beverages are not metabolically inert. The gut microbiome plays a critical role in mediating these effects. Emerging research indicates that artificial sweeteners can disrupt the composition and diversity of gut bacteria, favoring species associated with metabolic dysfunction, inflammation, and increased intestinal permeability. This leaky gut allows bacterial endotoxins to enter the bloodstream, reaching the liver and triggering immune responses that exacerbate hepatic fat deposition and inflammation. In this way, the gut-liver axis amplifies the risk of NEFLD even in the absence of sugar or caloric overload. Habitual consumption of zero-sugar beverages thus promotes a silent, indirect pathway to liver injury that consumers rarely anticipate. Behavioral factors further intensify the problem. Because these drinks are marketed as safe, low-calorie, or even diet-friendly, individuals may consume multiple servings per day, believing that they are making a healthy choice. They are often paired with processed foods, snacks, or meals high in refined carbohydrates, compounding the metabolic load. Unlike water or unsweetened beverages, zero-sugar drinks do not provide hydration without chemical interference, meaning that the liver continues to face stress from both indirect sugar compensation and additive-related metabolic disruptions. The risk is especially concerning for adolescents and young adults whose metabolic systems, gut microbiota, and reward pathways are still developing. Early and frequent exposure to zero-sugar beverages may establish a long-term pattern of altered appetite regulation, enhanced sugar cravings, and hepatic fat accumulation. For adults, chronic consumption can silently drive insulin resistance, low-grade inflammation, and triglyceride deposition in the liver, often before any clinical symptoms appear, illustrating the stealthy nature of this metabolic threat. In conclusion, beverages labeled zero sugar present an illusion of safety. While they avoid direct sugar-induced calories, the artificial sweeteners, flavors, and additives they contain can disrupt gut-brain signaling, alter appetite hormones, increase cravings, and promote compensatory overeating. These effects indirectly burden the liver, accelerating fat accumulation, oxidative stress, and the risk of NEFLD. The marketing appeal of zero sugar masks these hidden dangers, making habitual consumption potentially more harmful than consumers realize. For long-term liver and metabolic health, relying on whole foods, water, and naturally flavored unsweetened beverages provides a safer, genuinely low-risk alternative.